In this session, we're going to be exploring DORA metrics and beyond. We are specifically looking at improving developer productivity and reducing burnout with API observability. My guest here today is Ari. I'm going to pass it over to him to sort of introduce himself and take the conversation further. So go ahead, over to you, Ari.
Thank you. So, as said, my topic for today is talking about how you can use DORA metrics and what's beyond them. And I'm Ari Koponen, and I work as the head of platform at Swarmia, where we build a leading platform that helps the best software teams become even better. Our product has helped thousands of engineering teams become more productive, drive better business outcomes, and improve their developer experience. If you'd like to connect with me after this talk, you can find me on LinkedIn, Twitter, and Mastodon as AP Koponen. I also write regularly at our company blog at swarmia.com/blog. So go check that out if you're interested in content around software engineering and developer productivity. My talk today is at the intersection of API observability, which is what this whole conference is about, and engineering effectiveness, which is our core expertise at Swarmia. And the question I want to answer today is how can API observability make your engineering organization more effective in achieving its goals? And I will start by discussing the 4 key DORA metrics and then share insights on what lies beyond DORA. And DORA metrics are the most well-known modern software delivery metrics. They are well-researched metrics that have a proven relationship to your business performance. So if you're just getting started with improving your engineering effectiveness, they are a great place to start. Within the past few years, DORA metrics have achieved huge popularity in the software industry. And there are people who try to use them as a silver bullet for solving all productivity challenges of a software organization. This is, of course, not what they are. You can think of them as a good set of baseline metrics that help you understand if there are some things that you should definitely fix in your engineering organization. And the goal of using DORA metrics is to ship high-quality software as fast as possible. The first one of the DORA metrics is called time to restore, and it's the time it takes to restore service in production after an incident. As a general goal, you should be able to do this in less than an hour or on average. So how does API observability help here? Well, this one is quite straightforward. Better observability leads to faster recovery. Many incidents start as small, almost unnoticeable issues at the tiny corner of a complex system. Maybe a PR that was deployed and it resulted in a performance regression. Slowly, some of the queues you have start to fill up as your system cannot anymore keep up with the load. A customer notices this and starts asking why a piece of data is not updating. The customer support checks what is happening, but by the time they get to the product, the data has been updated. Maybe it was just a fluke. After some hours and a few customer reports later, someone really notices that there is a genuine issue here. You realize what is happening, you roll back to change, and in 30 minutes, the thing is fixed. But as a result, now you have more than 24 hours worth of backlog to process. An incident that could have been less than an hour ends up affecting your customers for a day or 2. Anyone who has worked with complex systems recognizes scenarios like this. On the other hand, if the systems that you've worked with have had some kind of observability in place, you probably also have plenty of the opposite experience. Your API response time started growing, an alert kicked in, and the change was reverted before an incident even happened. The second quality metric is called change failure rate, and it's the share of incidents, rollbacks, and failures out of all your deployments. Your goal should be to keep it low, below 10%. Well, how does API observability help us here? Well, all organizations that want to track change failures need to define what counts as a change failure. This is not often straightforward. Incidents are clearly change failures, but what about smaller bugs or performance regressions? When you start learning about API observability, you quite quickly come across SLOs, service level objectives. Defining good SLOs helps your teams keep track of their software's quality. And having API observability in place then allows you to actually know when you're not meeting your SLOs and what deployments caused those change failures. As a result, you end up learning much faster about what kind of changes caused these failures. Maybe you spend time refactoring code, maybe you educate people, maybe you improve your documentation and processes. Nevertheless, when you have good SLOs in place, you learn more, and this allows you to ship fewer bugs to production. The third DORA metric, which is also the first speed metric, is called deployment frequency, and it measures how often a software team pushes changes to production. Your goal is to be able to deploy on demand as many times per day as you need to. What's the role of API observability here then? Well, when engineers feel that they are able to catch issues quickly, they are more likely to deploy more often. Instead of ending up with no deploy Fridays, feature freeze Mondays, and please only deploy if you have 2 Tuesdays until there are not too many days left in a week, you can have people deploy on demand when they need to. This, of course, requires other DevOps capabilities to go with, such as automatic testing and the ability to roll back changes quickly. But no matter where you are in your DevOps journey, every team will benefit from having more confidence in their ability to know when things don't work as they should. So less risk, more deployments. And the last DORA metric is called change lead time. And it's the time it takes to get committed code to run in production. Your goal should be to ship changes in less than a day. So how does API observability help here? The more comfortable you are with catching bugs early and simply rolling back a change in production, the lighter you can make your QA and release processes. And this has a huge impact on your ability to ship and iterate faster. Of course, again, there are capabilities like feature flags that you need in order to be able to do this efficiently. But when you do, you end up shipping more high-quality software faster to your customers. So lighter QA, faster iteration. Now that we have an idea of some of the ways API observability can improve your engineering effectiveness, let's go and see what lies beyond DORA metrics. When you work on making your engineering organization more effective, you realize that it's a vast sea and it can be hard to navigate. There are 3 major areas of engineering effectiveness that you should consider when going beyond DORA metrics. The first one is developer productivity. And this is the one that people most often think about when they think about engineering effectiveness. Is your engineering organization making fast and consistent progress towards its goals? And this includes things like the issue tracker you use, your code review process, working progress limits, lead times, DORA metrics, and other frameworks like the SPACE framework that you might be using in order to understand where you're going and what's your speed. The second area is called business outcomes. And it answers the question, does your organization focus its investments on the right outcomes? And this includes things like how you structure your teams and what's the leadership structure? How do you set priorities? How do you balance investment? What are the projects or features or things that you put your focus and your time into? How do you manage cross-team initiatives, which are often hard? The third area is called developer experience, and this includes things like interruptions. Often engineers have too many interruptions in their day. It can prevent them from experiencing flow. Then there's the workload, meaningful work. Am I doing something that, I'm actually shipping something that I'm proud of? Am I able to do it well, or are the tools that I'm using always preventing me from doing so? And we can see that there's a long list of things here. So let's make it a little bit more concrete and briefly talk about how you might go beyond DORA metrics and use API observability to improve your developer experience and help reduce burnout. Let's discuss 2 major contributing factors to burnout: too high workload and lack of meaningful work. For engineers, these often are the result of too many interruptions that prevent them from getting to a flow state. To dive in, let's do a quick visualization of a developer's workday. Ideally, a developer should be able to spend as much time in flow as possible. The blue area in this graph represents the developer's flow level. So this person here is working uninterrupted and having only a lunch break in the middle of the day and a 10-minute light break every hour. They're getting stuff done and they're enjoying their life. Now, let's add just a few interruptions to get closer to reality. This is worse, but not super bad. Every software engineer has had much worse days. This person is still getting some deep work done while interacting with the rest of the company in things that may or may not be necessary. Most of the time, maybe. But you do see from this visualization how easy it is for interruptions to really mess up the day of a software developer. Now, let's take a look at the effects of a single high-priority customer request that gets immediately escalated. So here we have the first person who receives this customer request and they start acting on it. They have a long stop in their flow since they need to wait for the second person so they can solve the situation. Unfortunately, this person neither knows the answer though, so they need a third person to join and ask some questions. And the third person, unfortunately, needs to ask a fourth one. And here we are, a single customer request escalation costs hours of productive work. So how could API observability help here? Well, if we would have an API alert in place and it would ping the right person, we could actually remove the top two rows here. And the customer who originally had to do who had to contact customer support had a better experience since they would not have to reach out to support. Of course, this is easier said than done. Having just the right number of alerts is tricky. Nevertheless, it clearly shows you the power of observability in improving engineering effectiveness across your organization. Another thing about API observability and flow is that if you're feeling anxious about possible firefighting or incidents or the results of your PR being deployed, it becomes hard to focus on meaningful work. Again, here we have the ideal day versus a day of a developer who is feeling anxious about some possible production issues. They feel that they need to check the company chat or some production dashboards every 30 minutes, which ends up messing up their focus and flow. These kinds of days are sometimes inevitable, but in the long run, they will make the person feel that they are not getting anything done at work, which will increase their likelihood of burnout or attrition. If the developer can trust that there is enough observability in place and they will be notified if there's anything urgent, getting to flow becomes easier. Now we've seen some examples of how DORA metrics, API observability, and reducing interruptions can work together to improve the effectiveness of your engineering organization. If you're interested in learning more about engineering effectiveness, we just published a book called Build Elements of an Effective Engineering Build Elements of an Effective Software Organization. It is written by Rebecca Murphy, who has driven engineering effectiveness at Stripe and Indeed, and our CEO, Otto Hilska, who has successfully built and scaled multiple engineering organizations. It's available at swarmia.com/build. You can read it online for free or buy a physical or Kindle copy from Amazon. I highly recommend it. I hope this talk gave you some good ideas on how to improve engineering effectiveness in your organization. Please feel free to connect with me on your favorite social media platform. And now I think we have some time for questions.
Yep, feel free, anyone, if you've got questions in the chat, in the chat, which is open once again. I don't know why Zoom just doesn't do it automatically. Feel free to ask any questions that you've got. I'm wondering from so Ari, I'm going to take a couple of questions straight away from a developer productivity standpoint. How do you what would be sort of some of the key metrics sort of to define that developer productivity? I know you've touched upon some of those already, but when you say developer productivity, for somebody to understand who's not a developer, to understand the importance of why this is so very important, how would you sort of summarize that in maybe a couple of lines?
Well, the reason why we always sort of try to paint a full picture is that it's very easy to try and go and simplify things, as I said in the beginning of the talk about DORA metrics. There are some organizations that we've seen that sort of go like, they take all their teams and then they say that, okay, your DORA metrics should be this, and you should be continually improving on them. And DORA metrics are useful, and you should definitely like be able to deploy on demand. If you can't do that, then it's very hard to improve in many things. So you can start there, but then you shouldn't get too focused on this specific set of metrics. But if I sort of describe the journey that you probably could have, is that you can get started with something like DORA metrics and make sure your deployment pipelines and your DevOps practices are in an okay shape. Then you might focus on pull request cycle time. It usually shows if you have issues with teamwork, or if you are not able to structure your work into small enough increments. So instead of doing a PR in a day, you do it in a week. Usually it's too big, and then you get a bad review. So those are probably the two ones that you get started with. Then there are things like you might be trying to see if you're focusing enough on the right things. And then we talk about what we call investment balance. So you see how much of your work is going to the roadmap work. You might try to look into the key initiatives that you have, like what are the things that we're doing and are we actually doing them? This is actually a major problem. Like you don't have visibility into where the time goes. And this usually then leads to discussions, or at least if you're able to build trust in your organization, they lead to good discussions between like, hey, we are supposed to be shipping and why don't we do it? And then the engineers will go like, well, half of our time is going to firefighting, as you can see from this, that half of the time is bugs. So these are the kind of things that you then end up with, but each organization has different bottlenecks. So you'll find when you get on this journey, then you start finding out what are the things that your organization should be focused on. But DORA metrics, pull request cycle time, those are both the good starting points.
Great. I think Miguel mentioned something which is very close to my heart, because I've been delving into the world of platform engineering a little bit more and understanding the world of DevOps and SREs and sort of what that looks like, some of the philosophy behind why it sort of came into existence in the first place, especially the evolution of DevOps itself into the world of platform engineering. And I think one of the big challenges that at least platform engineering was or is trying to address is that whole cognitive load over developers, because like Miguel mentions, there is this in some companies, you're essentially trying to developers are essentially tasked to do 10 different things at the same time. So then how do you sort of navigate that situation? How do you then free up those developers to do what they're intended to do? Is that something that needs a specific cultural shift? Is that something that needs a champion with an organization to make it possible? It's a tough problem to solve, like Miguel mentions, but how do you sort of solve for this issue of, okay, a developer can do X amount of things. They should also do the ops side of things. They should also know about the deployment cycle side of things. So, the also keep adding on. So how do you sort of solve for that potentially?
Yeah, there's actually like in the book that I mentioned, this is from the business outcomes section. So the book follows these three main areas, and the first chapter is actually about business outcomes. And there's a really good section about how do you structure your organization to ship the outcomes that it should, and it discusses team structures. And this is exactly sort of the kind of thing that you end up in if you're not very mindful about what kind of teams do you have. Do the teams have the right expertise? Then do they have too much work to do? Then, for example, in the investment balance, often if people are working in a team that has too much on their plate, what you will see is that the amount of what we call the keeping the lights on work, so the work that is just trying to, keep everything together, fix bugs, fix production issues, whatever, that is very high. And that's an indicator that that team either needs more people or that it has too many responsibilities. So there's a culture change most often when you see issues, but the practical change is to start thinking around, like, are we resourcing our teams well? Do they have the right skill sets? Do they have enough people? Are their responsibilities well defined? And in many cases, for example, you might see that what you're describing now is how you would solve it is that you would build a platform team that handles a part of the stack, and then it provides some services for other teams that are then product teams that actually build the features. So in that way, you can reduce the complexity that the people in the product teams have to know, because some of the kind of systems are managed by the platform team, and then the platform team can have more expertise on operations and stuff like that.
I go back a little bit towards the sort of the team structure conversation that you just brought up as well. I think because I feel like that is very important now, because it sort of has that I don't know what is the best way. It's sort of the roles and responsibilities that lie with not just an individual developer or maybe a couple of developers, but actually has those well defined in terms of who's responsible for that. I'm curious, this particular slide talks about the engineering effectiveness and the business outcomes, the developer experience, all of that. It's all well and good to be able to track that, but it's also, I believe, equally important to be able to communicate that. So how would you say, what is sort of an effective way to do that? Is that, and whose responsibility is that? So sometimes you see that as engineering management roles have picked up, because I think one of the key areas that they look after is exactly this job, to be able to communicate and interact with other people, show the successes, show the progress. But who would you say is going to be sort of, how do you solve for communicating these metrics, and who do you think is going to be responsible for this?
Well, that depends a lot on the size of the organization. In smaller organizations, it's just going to be one person who is very excited about this, or the CTO, if they are they know what they're doing, so then they know that they need to understand this. Then in larger organizations, you often have some kind of developer productivity teams that are tasked to do this, to understand what is happening in the organization, what are the bottlenecks. Usually when you have hundreds or thousands of engineers, you find out that speeding up a particular build tool might save the organization tens of thousands of hours a year. So in those environments, it can be hard for a single person to see what should be done. But our tool and our philosophy and really how I see it is that it's always about empowering people in the teams to do this themselves. Like, for example, in our product, everyone sees all the same data. So you don't have like this secret manager dashboard where someone goes to see how things are going, because, for example, in the DORA studies, there's a thing called Western culture that speaks about what does it look like if you have a high performing culture, and it really boils down to do we have trust? There are other things, but if you don't have this mutual trust, then you stop communicating, and then people start hiding stuff. Engineers don't tell their leadership what is really happening, and then you lose this visibility. And you can try to build that, but then without building trust, and you may achieve something, but you will always have a bottleneck in the lack of trust between the people in your organization. Because if you don't get proper feedback, then you actually don't know what's wrong, and you might be even fixing the wrong situation. But really, if I would be the leader or the person trying to advance this, you always need a champion who has the resources to invest. But then the main goal would be to help the teams improve every day, give them the tools and the opportunities to improve their workflows, Build culture of, having retrospectives, not just in the teams, but maybe in the groups of teams, gathering feedback from developers to see what are the bigger bottlenecks that more people are feeling, and how do we fix them. It really, you can start it as a top-down thing. You can say that we want to invest in this, but unless you get the teams to join, you will be very constrained in what you can achieve.
100%. I think again, it goes back. We talk a lot about the technology side of things when we talk about observability, and that's why we've got this track around decision makers, because there is this cultural and people aspect of it is almost as important, if not more, to be able to understand and be on the same page, understanding that value drivers for observability at different levels, to be able to collaborate and sort of report on some of the key findings, as well as sort of the benefits, not just for external users, but also internal consumers, internal developers, and what that would look like. And from a cultural perspective, you're very right. If you're not being transparent about the things that you're doing, whether that is good or bad, then there is a lack of trust. And when that comes into the conversation, then, like you say, you're hiding behind some things. You're not going to be as open to trying new things out because you're too afraid of failures. And again, culture of an organization matters almost as much as the technology and the stack that are actually powering the product. So I feel like that's a really, really good point, and a great place to perhaps call it a day for this particular session. Is there any final takeaway that you would provide for our audience to say, this is sort of the one thing, if anything that you want to take away from today, this is the one thing that you should absolutely remember when it comes to developer productivity and where observability comes in?
Well, there will be rewards if you start on this journey, and it really doesn't matter on which corner of these three areas you start in. Start in the area that is easiest to sell in your organization. And when you get on that journey, you get the fruit, and then you can, you will dive in and it will grow. And that's just get started with the thing that is easiest for you to get started with. And then that will take you forward.
Fantastic. Okay. Start small, start easy, and then build from there and iterate and optimize. So it sounds like a great plan and strategy. Question from Kishore was about, where can I get the copy of the slides? So after the conference is done, everything, all the resources, all the videos, all the slides, everything is going to be made available. We'll send you a link once it's all ready and available to you. So don't worry absolutely about that. In the next day or so, it's all going to be in your inbox for you to try it out, along with the certification afterwards. So thank you so much. Amazing session once again, Ari. This has been incredibly informative. Thank you everyone who joined this session. We are now again going into a short break, which is going to be 10 minutes long. And then we'll be heading into, once again, two incredibly great parallel sessions on the decision makers track. This time we're going to be focusing on how to leverage API observability to meet product objectives and really exploring the product metric side of things, which is again something that came up before, tying observability into all of these different areas. And on the other end, on the implementers track, we'll be having the efficient way of auto-scaling your workload in Kubernetes using observability. So stay tuned. We'll be starting those off in 10 minutes. Thank you very much for being part of this, Ari. It's been really informative. Thank you everyone who joined. Until next time, until next session. Take care. Bye-bye.
See you. Bye.